Welcome to Skills and Academic Tuition Center. It is your favorite teacher, Kaumaji Mwansa. So in this video, we are going to look at G.C.E 2023 Science Paper 1 Section B. So basically, we just look at questions from question 1 to question 3. Okay, so question 1 is saying Elena carried out an experiment and obtained the following results as shown. Where necessary, we take the density of water to be 1 grams per cubic centimeters. Then we have been given the mass of the empty bottle, the mass of water, and as well as the mass of the liquid X. So now, the first question here is saying name the instrument that can be used to obtain the results of mass. So basically, we've been given the masses of different objects. So for you to determine the mass, there is an instrument that you can use. You can either say beam balance or electronic balance or the digital balance. So any of the mentioned answers is correct. So we go to B. B is saying calculate the volume of the bottle. So now, for you to calculate the volume of the bottle, you have to know the mass of the bottle, and at the same time you have to know the density of the bottle. So in order for us to calculate, from the question here we have been given the mass of the bottle full of water, and we've also been given the mass of an empty bottle. So that becomes easier for us to determine the volume of the bottle. So what we are going to do is we say volume of the bottle is equal to mass of the bottle full of water minus the empty bottle divided by the density of water. So we've used the volume of the bottle full of water because the volume occupied by water in the bottle is the volume of the bottle. So we are going to say 20 grams minus 8 grams divided by 1 gram per cubic centimeters. So when you say 20 minus 8, it gives you 12 grams. Then that divided by 1, which is going to give us 12 cubic centimeters as the volume of the bottle. Then the other one is we calculate the density of the liquid. So in order to get the density of the liquid, we have to say mass of the bottle full of liquid X minus mass of an empty bottle divided by the volume of liquid X. Mass of the bottle full of liquid X is 25 grams minus mass of the empty bottle, which is 8 grams, and divided by the volume of the liquid, which is 12 cubic centimeters. So now that 12 cubic centimeters is the volume of the bottle which we calculated. So this is going to give us 17 grams divided by 12 cubic centimeters. And when divided further, you are going to have 1.42 grams per cubic centimeters. So basically that is the density of liquid X. We look at question 2. So question 2, the figure B2.1 shows the same cone being placed in 3 different positions, X, Y, and Z, on a flat surface. So we have cone X, we have cone Y, and we have cone Z. First thing, define center of mass. Define center of mass. So center of mass is the point on an object where its mass is concentrated, or where its mass is seen or appears to be concentrated. We look at B. Identify the cone in a neutral equilibrium position. So from the three that we have been given, we have to identify one which is in a neutral equilibrium. Cone Y is in neutral equilibrium. Why are we saying so? So if cone Y is slightly displaced, it will stay in its new position. Same as the ball, when you roll the ball, you find that the ball will settle in its new position. We look at C. C is saying, state two factors that affect stability on an object. Two factors that affect stability on an object. So one of them is base area. The other one is position of the center of mass. So these are the two important factors that affect stability of an object. So question 3 is saying, the figure B3.1 shows the direction of four forces acting on a car whose weight is 8,000 newtons as it travels in a horizontal straight line. So the first question, which two forces should be equal for the car to move at constant velocity? So if a car is moving at constant velocity, meaning there is no acceleration. So now, which two forces are supposed to be equal? So there is the friction force and as well as the driving force. So we are saying force B and force D are supposed to be equal. We go to B. The table, we have a table B31 shows sizes of forces acting on the same car after it had covered a certain distance. So we take G as 10 Newton per kg. So we have force A, force B, force C, and force D. So those are the forces that we have been given. So the first question here is saying, calculate one, the mass of the car. So in order to calculate the mass of a car, we have to say mass of a car is equal to weight of a car divided by the acceleration due to gravity, where we have the weight of the car to be 8,000 newtons, then the acceleration due to gravity to be 10 newtons per kg. So that is going to give us 800 kg as the mass of the car. We go to question 2. The resultant force on the car. So the resultant force is equal to the driving force minus the friction force. So the driving force is equal to 1000 newtons. The friction force is equal to 600 newtons. So when you subtract those two, you are going to have 400 newtons as the resultant force. We calculate the acceleration of the car. Acceleration is equal to force acting on the car divided by mass of the car. So the force of the car divided by mass of the car. So for the force of the car, we are going to use the resultant force, which is 400 newtons, divided by the mass of the car, which is 800 kg. And when you divide, you are going to have 0.5 meters per second squared as the acceleration of the car. Thank you for watching.